This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the UPTIME podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the UPTIME Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, got a lot of wide-ranging topics. First, we'll talk about Australia. They're developing a sort of black box to sort of document everything that's going on with the climate crisis and sort of, I don't know, we'll talk to Rosemary, get her thoughts, but it's just to levy blame in case everything blows up. We'll see. But definitely an interesting concept. Obviously, time capsules have been around for a long time, and this seems kind of like around the same lines. We'll talk about de-icing wind turbines. We talked about Texas last week, and there's some interesting footage of a helicopter going to work de-icing a turbine. So we'll chat about whether that makes economic sense going forward, especially with other technologies out there. We'll chat through American farmers and how they get paid to have wind turbines on their land and what that might mean for all parties involved. We'll talk a little bit about some Biden orders on federal buildings using wind power. We'll also talk about Nebraska and some pledges they've made also by 2050 to get their decarbonization goals met. We'll talk about a few U.S. experts and how they're outlining efforts to optimize offshore wind efficiency. We'll talk about ExxonMobil, and they've recently purchased Materia, Inc., which they have some interesting ways to make wind turbine blades stronger. And lastly, we'll talk a little bit about superconducting magnets and whether they're going to be in our suite of technology anytime soon. So before we get going, be sure to subscribe to UPTIME Tech News, which you'll find in the show notes or description of this podcast. Also, be sure to subscribe to Rosemary's YouTube channel. She continues to put out great new live streams twice a month, along with all of her regular videos on everything wind and renewables. So definitely check her out. You'll find that in the show notes below. So let's get started with Rosemary. Australia has a black box to sort of hold all of us accountable. Rosemary, what's your take on this?
So I guess that they're recording a bunch of stuff off the internet, climate data and energy use data, so that whoever shows up after we blow the planet up can know what country that doesn't exist anymore was to blame. So, I mean, I'm not sure I see a lot of practical use, but other than maybe it gives some sort of, I don't know, like you give the feeling that you don't want your country to be the ones that the aliens blame for the climate apocalypse. So I guess that's my take on it. They've put it in Western Tasmania, which is, I would confirm, a good place to put it. It's pretty hard to get there. So I think it will, it will last for a long time, and maybe it's a good opportunity to plan a trip there. I have been planning a trip. Planning to go to Western Tasmania for a while. My dad's from Tasmania, so has a soft spot in my heart.
Well, what do you think? I mean, you're both engineers. How do you engineer this black box to endure, like, what it needs to be accessible to another human, so they can't just like fill it with concrete. They can't just bury it. And how do they find the balance of this is completely obviously off topic, but just this is what fascinates me is they made this box. How durable does it have to be to last 200 years, 500 years? I mean, when do you guys think we're going to be exterminated as a species, number one?
No, but it needs to last until aliens find the planet or some other species evolves intelligence to open it, right? So, I mean, it's got to last millions of years, I would have thought, as at a minimum, probably hundreds of millions.
So is it going to have hinges? I can't wrap around my head about what this thing looks like and how it can be both insanely durable, but yet also openable. Or are we just assuming they're going to have some sort of laser torch, just like cut it open with like their fingertip, like at ET or something? Just, I don't know. Alan, what's your take?
Yeah, it's a little weird. I never understand the purpose of that blame game that's going on right now, and assuming that the world is going to end, so let's just prepare for the end and just call it quits. I'm not sure we're near that right now. And to put a bunch of money and time and effort into some project like this is interesting, but maybe not really useful, because it seems like there's so many other ways to mark the territory, like, hey, ET phone home. I'm not sure this is the way to do it, because I think, Dan, in the dawn of humanity, not many things have lasted millennia. Because we haven't really been on the planet all that long. Probably the oldest objects on the planet are probably the pyramids, maybe something around that time. And even that is not going to be there a couple of thousand years from now. So that's just a really interesting premise that you can think you're going to document the history or the decay of the Earth, and someone's going to be able to access it. And I'm not sure what they're going to do with it, because everybody's going to be dead. So it doesn't even really matter at that point. Right. So, but I think if we consider this game that we call the Earth to be over, then why put any effort into it? I think that's the trouble with projects like this. If we just assume that it's all going to go wrong, then we might as well give up now, which a certain part of the population will do that. So the argument actually works against you. Instead of encouraging people to join the club and let's do this thing, there's a 20-30% of the population will say, oh, let's just kill it all. Not sure that's helpful.
That guy from the bird group, ABC, is like, yeah, well, I understand we need wind turbines to solve climate change, but I don't think we're going to, so we might as well go out with a bang. It's like, yeah, it's not my personal philosophy.
Mine either.
Well, I see the way we save all this is some sort of like Fifth Element sort of scenario where we have like some stones and a super being, and then they just, shoot that big ball of light up into the sky. And that solves the climate crisis in like 35. So that seems like the most obvious solution. So moving on, Rosemary, there's a YouTube video we found of a plane de-icing, or a helicopter de-icing a wind turbine blade, heavily iced. And this seems something that's just really expensive, really impractical, but at least from the photos that we've seen, the video we've seen, this is a very heavily iced, frozen wind turbine. So obviously you worked on de-icing systems. Is this something that's actually like in use consistently, or is this just something like really in a really, really extreme rare case?
It's more on the extreme rare case, but not as rare as people say. People seem to think. Like when I look on LinkedIn posts and, that photo crops up every now and then, like several times a year. And it's nearly 10 years old now, and it's from Sweden. And it was part of a trial to find ways to get iced up wind turbines operating again. People say, oh, that's not done anymore. We have heating systems that we put on blades. And so that's old news, fake news. That's not quite true either. It's kind of somewhere in between them. So yeah, I worked on blade heating and de-icing for over 4 years. That was my job when I was at LM Wind Power. And what I would say is, unless you have icing losses on average of 5% of annual energy production, then you shouldn't install a de-icing system in your blades. It's quite expensive. It adds a lot of maintenance as well to the wind turbines. So people want to avoid that. And the economic break-even point is somewhere around 5% losses. So, that means what, like there's 50 weeks in a year. So it's like 2.5 weeks, your wind turbines would need to be iced up every year on average. And if it's less than that, usually you're going to be better off just, waiting for the sun to melt the ice off. But if you're looking at several days of downtime, then it actually does make sense to get a helicopter there, spray warm water on the blades and de-ice them. You can, if you've got the helicopter in the area and a lot of turbines to de-ice, it will pay for itself within a couple of hours of, of extra energy that you're generating. And the same for the energy balance. If you're get your wind turbines up and running and displacing fossil fuel generation, then it is actually positive for the environment overall. It's kind of one of those things where I think people say like two extremes. One, wind energy, it's not really green because they constantly have helicopters flying around de-icing them. And that's not true. But on the other hand, people say, oh, that's fake news. That never happens. And that's also not true. But yeah, it's not that common, but sometimes it just is the best thing to do.
Well, you wonder if that'll come back around maybe in 5 or 10 years, because obviously we saw, Alan, was it Arones that they sort of jumped to fame and got their bid with Y Combinator because of that drone they made that was, it was powered by an electric cable, so it could stay up indefinitely. But that was it cleaning a turbine?
Washing the blades.
I mean, you assume as drone technology continues to improve, at some point that might just come back around where it's like, yeah, we just have a fleet of drones. And if any of them go offline, they just go up and sort of do their symphony and just do it. They can the drones just come back and refuel or reload up with fluid, or they just have a continuous hose and whatever. So, we'll see as drones continue to be able to do it more and more. But right now, obviously the flight time is one of the limiting factors with some of them. Of course, with industrial drones, they have pretty good flight time, but yeah, so that again, it's always a good, to address some of those interesting photos, because you don't know what, like you said, what's fact and what's fiction. And it's an impressive and interesting photo video of that helicopter de-icing. So moving on, American farmers, and this has been going on for a long time, they're paid to have wind turbines installed on their land. So if they identify a good site, say in the Midwest, which I was actually out there this weekend talking with a lawyer friend of mine we were just talking about, wind energy in Illinois, and he was saying, oh yeah, a lot of these farmers have a pretty good deal. They make up to $7,000 per turbine per year on their land, and of course, if it's say 6 farmers, they might all just pool where, if they're getting revenue from 100 turbines, it's not going to be, there's 52 on John's land and only 10 on mine. They're just going to say, all right, we're all in the same network, so we're all just going to split the profit evenly because we're on the same area. And it just might not make sense to distribute all the turbines on one of our land, or just distribute them evenly. They want to make sure it's optimal with the wind farm. So, Alan, this seems like a pretty good deal for American farmers who obviously have struggled to make ends meet. And of course, they've struggled in part for the same reason that wind energy might be struggling, with prices being driven down. So it's like corn commodities and soybeans get driven down. It becomes very hard to make a living. And we've heard last year, especially with COVID, that farmers were dumping milk and dumping potatoes and dumping other crops that they didn't have. It's cheaper to do that than to actually take them to market and sell them. I mean, Alan, what do you think is this going to continue to help American farmers?
Yes, and I think the farmers and the local community should demand it. And because it does two things. One, it puts some cash in desperately needed places. When downturns happens in the farming community, it's really hard. And that's, over the last 30, 40 years. If you remember, really, Willie Nelson used to do concerts called Farm Aid, and that was there to support the farmers that were just the small family farmers were being sort of gobbled up because of the amount of cash you'd have to spend every year just to keep alive. You had one bad year, one bad crop, or not maximal crop, and you were broke, and your farm was acquired by a corporation, and all that happened. So there's been some stability there a little bit over time, but any sort of outside income is great for farmers. And I think as long as the community wants to participate with that, and I think the sharing piece makes a lot of sense, then it makes it easier for everybody, right? Because there is an inconvenience of having wind turbines on your site, obviously, and it is your property, so you do have rights over it, and you should get compensated for the energy that it produces. And I think that all makes sense. And as we go forward, I hope we see that continue. I think one of the issues we're going to have with offshore wind is that'll go away, right? That the federal government will just take all that money that would have been distributed maybe to the local community, and we lose that sort of nice little piece between wind and the community, because that does build better relationships. In fact, in places where those relationships do not exist, where there's no income stream coming from the wind turbines, there's a lot of animosity. So a little bit of cash and spreading out where the proceeds of all that hard work does seem to pay off in terms of success for the project.
Rosemary, you're well traveled. Do you know, does this agreement exist outside the U.S.?
Yeah, I know similar in Australia. And I think I was looking into this a little while ago because one of the things that people comment a lot on my videos, especially when I'm talking about vertical axis wind turbines, is people are always coming up with ideas for ways that you could pack wind turbines closer together and get more. The idea is that you get more out of a certain amount of land. You know, if you have an acre of land, that you could put more wind turbines in that per acre than you could with the normal horizontal axis wind turbines. And so this point, I was looking up, trying to get some information on how it actually works. And yeah, like you said, the farmers get paid either per turbine or per megawatt is another way that it's done. So if it's a bigger turbine, then they get paid more. And I did find a report on operational expenses for wind turbines in the US that actually gave a breakdown for some of the wind farm operators that gave data broken down to the point where it said how much per kilowatt per year they're spending on land, and it's like $4 or $5 per kilowatt. So that makes sense for, so 5 to 15,000 a year, depending on the size of the turbine. So yeah, if you instead got a bunch of smaller turbines and packed them in closer together, then you'd probably end up taking away land from being able to use for other farming uses, because more turbines, the more roads. And then the other thing is that you would end up having to pay more for that because you're using the land more intensively. So it's really not beneficial to pack wind turbines in have heaps of small ones close together. And this is one of the reasons. And then I also wanted to talk about another point where you said that as wind farms are moving offshore, we'll see less of this. And I think if communities want onshore wind farms, that will still, for a long time into the future, maybe forever, be the cheapest way to make wind energy. And I think probably the main reason why they're going offshore is because a lot of communities don't want them. So I think if in Australia, we're starting to see new development sites kind of based around zones where it's pre-planned a little bit with infrastructure in place and, crucially, community involvement. So, they find the community that wants the wind farm, the community that wants the jobs, not just from construction, but, like wind turbines need a lot of maintenance. So there are technicians that need to stay on site afterwards. And, if communities want that, I think that there's still going to be a place for onshore wind farms well into the future. So, I think that's an important point.
Yeah, and another side note of my recent trip to the Midwest, as I was flying in, I was watching this pretty large wind farm in central Illinois that we passed over. And the houses were very close to these turbines. I mean, most of the Midwest is kind of patchwork, it's kind of, I wouldn't say they're not block size, but they look like blocks, right? And in lots of stretches, they're very uniform. I don't know if they're 1,000 feet between stop signs or whatever, but there were a lot of houses, and I took some photos, but there are a lot of houses that couldn't have been more than 1,000 feet from some of these turbines. I know there's an ordinance, so I'm sure it's a uniform, I'm sure there's none that went 100 feet or 200 feet, but it looks like there are a lot of them were pretty darn close. And it just struck me as odd, considering of how many stories we reported on of people suing, for wind turbine syndrome, or just the amount of complaints given the proximity to them. But I'm not sure whether this wind farm has those complaints, but there are a lot of people who seem to be coexisting very much in this little forest of wind turbines. So moving on, Alan's neck of the woods to Nebraska. So they are the first Republican-led state in the U.S. that has voted to set a decarbonization goal of net zero emissions by 2050. So, Alan, you were born and raised in Lincoln, Nebraska. Is this a surprise to you, knowing what you know about Nebraska and their politics and their energy sources and goals?
No, I think Nebraska has always had a unique set of parameters around energy. And it's been basically smaller communities. In my town, we had our own electric system, Lincoln Electric System. So it wasn't like it is here in Massachusetts, where it's a much larger system. They tended to go city by city, town by town, area by area, county by county, a little bit. Same thing for telephones. So they've had their own independence for a long time and could set their own parameters as to what they want to do. And obviously there's a lot of wind energy in Nebraska. It's just a place where it's windy and there's a lot of flat land, and it makes it a great place for wind turbines. Same thing for Kansas, Oklahoma, Texas. And I think Nebraska does have a nuclear power station, or they did at one time. So they have a variety of energy sources, and they're trying to get rid of coal power stations and clean the air. The farmers and the communities would all demand that, I think. The one thing about this that's a little troubling is this sort of Republican-led state, Democrat-led state. Oh, Nebraska is the first one to be a Republican. How the Republicans are finally learning the value of wind. That is just a really bad argument because your largest wind producer in the country is Texas. And that's been a quote unquote Republican state for a long time. And the ones that come to second, third, fourth are also probably Republican led states, because that's where the wind is. It's right in the Midwest. So to sort of throw the political part into it is not really useful. I think if you want to promote wind energy in the Midwest of the United States, you need to do almost nothing, right? The wind is there. The infrastructure's there. The construction people and all the technical people are all on site, are ready to go. It's proven itself successful for the last 20 years. It's going to grow naturally, right? And I think the Clean Power Association and agencies like that just need to say, great, this is awesome, keep going, not to bring political opinions into the discussion, because it doesn't benefit anybody. It just draws a line where no line needs to be drawn.
Alan, do you think other states are going to follow suit now that one Republican state has sort of, like that domino has fallen?
No. And I wouldn't expect them to. I don't think Texas will. I don't think Louisiana, Missouri would follow. Maybe Missouri, but Iowa probably will. But I mean, there's just a difference in the political ground war that goes on there. But in terms of what's right or wrong, I think the beautiful thing about the United States is it's really 50 independent states, and each of those states can do their own thing within parameters. And that's where we're going to find out what's optimum for Idaho. It's great for Idaho and may not be optimum for Missouri. Great. They're all going to have to find their own solution. And if 100% renewables in Nebraska is the right answer, then great. I mean, I wouldn't force that on anybody else, because it may not work in Florida.
Well, moving on, let's talk about Biden's recent order to get federal vehicles and buildings to use renewable energy by 2050. Alan, there's 300,000 federal buildings, 600,000 cars and trucks. The government purchases over $600 billion in goods and services. Is this, obviously 2050 is a long way off. That's 28 years. But obviously these things are a long time coming. That's a ton of equipment to purchase over time. It's a ton of buildings to convert. What's your take on this? Is this a realistic goal? Is this one of those, another sort of pie in the sky thing that just sort of is a little bit of whitewashing, like looks good, but might not ever happen? Or is this just like, hey, we do need to get this train kind of rolling? I
don't think there's any way to be able to measure it or to know in the Biden administration whether any action has actually happened on this or not, which is why if you're a politician, this is an easy one. You can just say it and no one will ever measure it on you. And if nothing happens, you say, well, it's just going to take time. If something happens, like, oh, look all the progress that we made. So there's no way to lose in this argument. The weird thing about the Biden administration, which is unusual, is the whole thing about electric vehicles. Like, they have completely tossed aside Tesla in the discussion about electric vehicles. They're more than congratulatory to General Motors and Ford and who knows what Chrysler's doing today, Fiat's doing today, about promoting renewable energy vehicles, electric vehicles, and they keep Tesla out of discussion all the time. So if you're really serious about you having more renewable energy and also having more electric vehicles, Tesla has to be at the table. Rivian, which is a car company that's developing in the United States, probably needs to be at the table. And they're not at the table. I mean, to leave Tesla off, which is selling more electric vehicles than General Motors, is crazy. Right. And so it makes you question how real the Biden administration is on other aspects. Like, is it just about the visibility, the press, or is it actually about something concretely real happening? Because if I want to promote renewable energy and I want to promote electric vehicles, I probably want to have Elon Musk at the table than to just ignore him. And so that's the weird thing about what's happening now is like there is this dichotomy of either you're in the club or you're out of the club. For whatever reason, Elon Musk and technology people like him are out of the club. And I'm not sure that's smart for America. I would say it's not smart for the world. So I think this discussion about the Biden administration is always interesting because I'm never sure where they're going. Obviously, we should applaud them when they're going in the right direction. I think offshore wind is probably the right direction. But the federal building, maybe the electric vehicles, that one is really up in the air, I think.
Yeah, I mean, as far as leaving Tesla out, I definitely don't see the logic in that. But some of these other companies like Rivian, I saw a Rivian truck in the wild this past week, by the way. I love this. Yeah, I love the styling of their vehicles, but like Rivian is still unproven. Like, how many cars have they churned out, right? Like, having them in a long-term conversation is like having any startup in a long-term. It's like, well, let's wait 5 years and see if you're still here, with, all the optimism in the world, but still, like, we don't know what's going on. Tesla has sold a lot of electric cars, like they're here, right? So I don't know, but I mean, this is definitely a long-term goal. And I think you're right. There's definitely some bias that seems like it's, for these long-standing companies like GM, which, yeah. And of course, this whole idea of the electric car being a disruptive thing is one of those things that's hard for big companies to figure out. You and I were talking off camera earlier about how some of this book, The Innovator's Dilemma, talks about, microchip manufacturers and hard drive manufacturers in the past, and how when you have a really large customer base that wants an existing product, it's hard to divert the engineers and the research money and the facilities and all this stuff to suddenly making this new disruptive technology that doesn't yet really have a clear market. And that's why a lot of these companies, and the excavator market was another one, the transition from cable driven excavators, previously the steam shovel, to cable machines, and then to hydraulic excavators, which we all know today. That was also one that took a long transition because the new technologies were smaller, didn't fit the existing market. And the electric car was something that no one was asking for a long time. And that GM and these others were like, why are we going to develop all these resources when, we don't see this as viable? We're going to keep focusing on gasoline powered. And of course, Tesla caught them, passed them. Here we are. Another discussion, but still, it's interesting how the things have changed.
Yeah, I think it's the same discussion. If I think the one thing that's been tossed around here for the last several in the United States, the last several years, is sort of the Green New Deal, that we need to greenify every federal building. Do you realize how much that energy that's going to take and time that's going to take away from other things? I get it, right? And I think there's ways to make it more efficient. There's ways to power them. That are greener. Okay, those are the easy ones, right? But if you're going to have to throw solar panels on thousands and thousands of buildings, that's just not something that's realizable. It's something a politician says, but an engineer just goes, no. It just, that's not a good use of time. There's a lot of the things we can be doing. Let's not waste time and energy on literally 100 or maybe 150-year-old building. That's not where we need to be spending our time. And I think that's that's the things that sort of Rosemary and I see. Like we're in the trenches having to do some of the heavy lifting here. And there's places where we need to spend time and there's places that we don't. And if you're looking to get to a faster renewable energy future, you need to let some of these other things sit on the sidelines or you spend more time on the goal.
Yeah, I think that it's interesting when people say, oh, so the government should lead, and I agree that they should lead, but it's like, is it scalable or not? So I'll disagree with you on the point of solar panels on houses, because in Australia it's a totally different story to the US, where it's like 30% now of houses have rooftop solar, and it's, if you add it all up, it's the biggest generator in Australia now. And I've been looking at, we've got this grid software where you can see like the energy makeup of the grid, and you go to South Australia's grid and it's like entirely filled by rooftop solar at some points now. It's crazy. Like you would, as an engineer 10 years ago, I would have said that can't happen, and it has. So in Australia it's worked, maybe not. In the US I know it's a lot harder there, and installation is a lot more expensive. But I think that some things governments can do make a lot of difference, like electric vehicle fleets. That has a really big impact, because you can get they're buying a lot of new cars, and also they sell them quite quickly. So then all of a sudden there's a secondhand car market, and you get, sorting out a few teething problems with businesses who, have the time to spend sorting it out. And, the payback is quite good economically already for fleets. So I think those sort of things make sense. But like you suggest, like a lot of times people say, oh, every government building should make its own power from solar panels and wind turbines on the roof. And it's like, well, what's the point in putting a wind turbine on the roof? It's going to cost a lot more and make a trivial difference. And to me, wind turbines on commercial buildings, it's always greenwashing, like 100%. Even if the company is legitimate, does have legitimately good green credentials, the wind turbine is not part of it. And I would really much rather see people use the money and the effort to solve the problem. We need a clean energy system. Like all of it needs to be clean, not just the government buildings or the people that want to feel good about themselves. Take your good intentions and put them into something that makes a difference. And that's what I'd like to see.
Well, yeah, I think in America it is different than Australia in the sense that there's 330 million of us, and it's a little bit harder because we're all spread, and it's a large country too, so it's kind of spread out. But I think one of the fastest way to get to where you want to go is to let the citizens drive it and to take some of the barriers away from doing some of the heavy lifting. And I think we're seeing that now in certain spaces where the population and the creative people in the United States and around the world, honestly, where they have similar systems, are able to do it faster than the government can do it. The government is bounded by all kinds of constraints. The individual, hopefully not as many. And if the government would help remove some of those barriers, I think we could see that energy transition happen faster rather than sort of the plodding, bureaucratic way that would typically happen with government leading it. And that's what I see in America.
Well, if we let the citizens vote, I vote that they transform the ugliest, brutalist architecture buildings in DC first. Because if you haven't been to DC later, we have some very, very ugly concrete federal buildings from the 1980s or 70s or 60s.
But is it literally brutalist? Because we have some of those in Canberra, the ugliest, just plain concrete blocks, and they're heritage listed because apparently they're very architecturally significant. I have an architect friend who loves them. That's the worst thing I've ever seen.
Yeah, your architect friend has bad taste in buildings.
He has good taste in general, but just really likes brutalist for some reason.
There's nothing to love there.
The Biden administration just authorized that again. Through the Trump administration, they were going to stop the concrete building thing and make buildings that look nice. And Biden's, for whatever reason, stopped that.
Wait, what?
That's true. Look it up.
That's a real thing?
Yeah. Yes.
No, but didn't Trump have this specific idea of what a building should look like, and all buildings should be made in Trump's particular favored style? Wasn't that how that worked?
No, I don't think so. I don't think that's how it was set up.
His MO, but
it would be how it would work, obviously, because it wouldn't work that way. But you're right? It's funny how we lend credence to the government's we think the government's going to be successful at doing things, yet we don't look the track record of sort of mediocrity, a lot of things that individuals been able to, or companies have been able to do better. And we should let it sort of develop naturally. I think a lot of it would happen. And the wind turbine industry is no different, right? I think it's been around for a long time now. And just because of people like Paul Geip and, that cast of characters that were there early on have driven it to where it is today. They may not agree with the direction it's gone, but it wouldn't be this far if they weren't there at that particular time doing the hard work and getting it off the ground. I think that's really important. And that's how we're going to be successful in the future.
Well, last comment on buildings, and love them or hate them, Mr. Trump didn't build this building, but the Trump Hotel is stunning. It is a gorgeous building.
In New York?
No, in D.C.
Oh, okay. I've seen the Trump Tower in New York, and I would not describe that as a beautiful building. It's flashy, I guess you'd call it that.
It's magnificent. And of course, a lot of the Felder buildings that are made of marble, and I mean, they're beautiful too. So it's weird in DC, the dichotomy of just amazing buildings and these concrete things that they allowed themselves to make. So moving on, there's an interesting article from Innovation News Network about how to optimize the efficiency of offshore wind farms. And here's a quote from Sarah Pryor, who's a professor of Earth and Atmospheric Sciences at Cornell. And she said, massive upscaling of wind turbine deployments offshore is critical to achieving global and national goals to decarbonize the electricity supply. And Rosemary, I'm curious, what does she mean when she says massive upscaling? We just need more volume of it to get better at it, to do what exactly?
Yeah, I mean, I guess it probably means both more wind farms and bigger wind turbines, but overall the important thing is more gigawatts of offshore wind. And I agree that it's really important, and I think that it's I don't know. It's interesting. In a way, it's hard to see why there is such interest in offshore wind when it still costs twice as much per megawatt hour as onshore wind. But then I think it's because actually we value a lot more than just the price that we pay for electricity, and we're still in the process of figuring out what our values really are. So offshore wind has the value of not bothering anyone aesthetically, if it's put far enough offshore anyway, and no one has to live right next to it. But so it's got that extra value, and also there's really good wind resources offshore, which is another thing. But if you're valuing, getting people and jobs out to the regions, and allowing these regions to become more prosperous again, then if you value that, then you wouldn't have more offshore wind turbines. And I think at the moment we are really in need of figuring out, or every society needs to do it for themselves, but figure out what do you want out of your energy transition, because renewable energy and all the clean energy technologies, they're so flexible that we can have what you want, but we just got to be clear on it. And at the moment, I think the last 10, 20 years, we've kind of assumed that everyone just wants the lowest cost possible, but we are starting to see some more community opposition. In Australia, there's some wind farms that are being put in areas where you need to clear some trees for access roads. That there's a fair bit of community opposition against that, and a few other things that are maybe also transmission lines. I know it's a problem in America as well. We need so much more transmission. I mean, we need it regardless of what happens, but people don't want it on their land necessarily. So is it worth it to spend more to bury the cables? Is it worth it to, not clear any more forest and put the wind turbines offshore? We need to have a clear set of priorities to be able to make those decisions and end up with an energy system that we want. It's not like renewable energy doesn't have to look in any one way if people don't want it to, but we need to be, clear about what we're trying to achieve to get a good outcome.
Well, Rosemary, don't you think that's why offshore wind exists, is that it removes so many governmental barriers from the start of a project till the completion of it? If you're doing it offshore, a lot of those just go away, right? They're talking about putting the transfers and the substations, they're floating them now, and they're only going to have one feed coming into shore every once in a while, and they're spreading out where these in the east coast of America, they're spreading those wind farms out so they don't have too much impact in any one local community. You can imagine if you took those same wind turbines and put them on shore, how much of a fight you'd have from the state, local communities and all the environmental hazards reviews and all the things and the transmission lines and all that have to happen. What everybody's saying is, hey, the simplest route is just to put them offshore. Yes, it's going to cost more to produce energy out there, but it's going to get there faster than us going through 10 years of review cycle onshore. And I think that's where the trade-off's being made. But I also think that the price of electricity on the East Coast in particular seems to vary quite a bit. New York has crazy high electricity rates, and not many renewables for that matter. And then as you go further south, it seems like the price of electricity drops. So New York's more able to absorb the higher energy produced offshore than maybe South Carolina would be. But at the balance of the day, I think, because of people like you, honestly, that the cost of energy, even on offshore, is going to be driven down dramatically over time. Give us 5 years, right? Give us 5 years. Give us 10 years. We'll drive that cost of energy down, and hopefully it becomes really competitive. And I think that it will. When there's so much mass and force put behind something like this, and there's so many engineers working hard to lower the cost down, I think it's just a matter of time that we get to that sort of sweet spot we've been looking for. I guess, the wind turbine manufacturers are complaining about not being able to sell their wind turbines for enough money, and the cost of energy may be a little bit high. Those things are going to balance out over time. I mean, we're going to, I think at the end of the day, we're going to be okay. And what we learned from this huge expansion of wind energy off the coast of the East Coast of America, I think we'll have applications other places. That we're going to learn some of those hard lessons now. But when Japan or India or Vietnam, it sounds like, or South Korea goes after that offshore wind, they're going to be at a better place. It's going to be more capable, a better levelized cost of energy, and less impactful by the time they get to these other countries. And then that's good, don't you think?
Yeah. And I think, so offshore is expensive compared to onshore wind or solar, if you're talking just purely the cost, not necessarily. I know that there's some benefit for offshore wind is in some places it better correlates with loads, so you might get a higher price for electricity. But I think it is already cheaper than coal. I'm just looking at the latest Lazard levelized cost of energy version 15, and I think that at $83 a megawatt hour, that's still less than coal is. So I think that's probably the more crucial point. I think we'll continue to build onshore wind farms where they're wanted for a long time. And I think that we need such a fast expansion that they're not really in competition. I think that both are going to go as fast as they can, kind of independently of each other.
Well, because half the population of the United States is along the coastline. Okay, that's half. You took care of half the population. What about the other half? The other half lives somewhere inland, pretty far from oceans. You're going to have to do both to be successful as a nation. You can't just do one and not the other.
So moving on, ExxonMobil has acquired Materia Inc., and they're a company that they have some pretty strong technical advancements in polymers. And, it looks like ExxonMobil is after, this, or was after this company, to kind of, improve their portfolio of technology and some new thermosets. But obviously you two are both experts on composites. Alan, I'll jump to you first. What sticks out to you about this acquisition by ExxonMobil? Because, a lot of the materials that Materia makes are great for making more durable wind turbine blades. And why is that important to ExxonMobil?
I think some of them are petroleum-based. Most of it's petroleum-based. So it's a natural outgrowth of the petroleum business. And it's in great need, right? I mean, one of the issues that we're having on the planet in terms of developing new products is thermoset resins. It's sometimes hard to get, and carbon fiber is hard to get in places. So there's a definite marketplace for it. The wind opportunities, I think, are limited just because of the types of materials we're going to be going for in the next 5 to 10 years. And it always feels weird when, and Rosemary's going to tell me this, I can feel it coming. It always feels weird when ExxonMobil buys somebody because you just feel like there's a cigar-filled room, and maybe it's just the way their name has been associated with this over time. Like anything ExxonMobil does, you just feel like there's just a big conference room table and these people smoking cigars. Like, oh yes, we're going to conquer the world with petroleum. Okay, yeah, but but I don't think that's true. I do think a lot of they have a value right now, right? I mean, there's a reason why ExxonMobil. I didn't need to put oil in my car so that it runs. That's an ExxonMobil product. I kind of need that. So there is something of value of the company. We can't poo-poo it. I think that's the wrong answer too, but we can also nudge it. Right. Corporations like that can be nudged into particular directions. That's what the stockholders are all about. And the stockholders can make a difference on who's in the management eventually. And Rosemary, don't you see that as the sort of the way forward, is that the people that own the stock or sell the stock or buy the stock going to have some say in the direction they're going?
Yeah, I don't interpret this as Exxon branching out into renewables at all. I mean, I did a quick search in case for news in case they've changed their tune. But the last I could find, they're still saying that there's, no economic return on renewable energy investments compared to fossil fuels. And so they're not going to do it. So I don't think that they think that this is going to have anything to do with, like backing the wind industry. I think that they probably see it as a way to slightly hedge against, future uses of fossil fuels. And I mean, we still will need like a decent chunk of the fossil fuels we use today. I think maybe it's like around 10% are not burned. They're used as feedstocks for, making plastic or whatever. So, I mean, that will largely continue. I mean, it's not going to have to decrease for climate change, maybe for other environmental reasons. But I don't think it's got much future in wind turbine blades because, as you mentioned, like it's not the direction that people are going. People are really focused on making recyclable wind turbine blades, and so it's got to go towards thermoplastics surely in the future. It's not so relevant if the carbon intensity of the particular resin is lower for this. I mean, it's so marginal anyway for the total life cycle emissions of a wind turbine, the emissions associated with the resin. So I don't see that it's environmentally friendly. I think that like maybe it's an interesting product, but I don't see it as having real logical connection to wind or renewables or representing any kind of shift in direction. And I'll say that's in real contrast to a company like Shell, who actually, they're still involved in fossil fuels. So a lot of people are, really skeptical of any green announcement they make, but they are making investments for that they believe in renewables projects. And I do think that it can get kind of philosophically shaky to just instinctively oppose anything that a fossil fuel company does. And I did meet somebody at the conference I was at last week who's been in the renewables industry for a long time, and he has just taken a job at Shell because he believes that they are legitimately trying to move in that direction. And it occurred to me, if no one who cares about climate change will work for any of these companies, then they can't change, right? So I do think that, like, I'm skeptical. I'm not going to just, blindly believe that everything's good and ignore all their existing fossil fuel investments. But I'm also not going to, just like, I don't want to punish fossil fuel companies. Even if they deserve it, I'm really more about what's the fastest way to do this transition. And any fossil fuel companies that want to get on board and move in the right direction are only going to speed that up. So, I'm definitely open-minded for fossil fuel companies that make the right steps, but I don't put Exxon in that category yet.
Well, and they also might be in trouble in the future. If companies don't get on board as technologies change, we'll see how that plays out for them and all of them. So, getting some amount of your portfolio expanded is going to hedge, some of those potential woes. So last on the docket today is superconducting magnets. And this has been something that they have been looking into for quite a while because the potential to reduce generator size is pretty significant, especially as offshore wind turbines especially get, gigantic. But Alan, I mean, first, can you kind of sum up for us, why superconducting magnet, and they're using magnetic tape, why is it such a benefit to potential wind turbines in the future as they get bigger? And why is it proving so difficult to get this to market?
Well, the superconductor push has been happening for 50-ish years. Basically, a copper wire has resistance, and you use a lot of copper wire in a generator or a motor. And there's a lot of heat losses in a generator or a motor that are due to the copper resistance. Even though copper is a really good conductor, it's not as good as a superconductor, which has essentially zero resistance. And there's some weird physics associated with that. And they've been driving down the the superconductors tend to live at really, really cold temperatures, like near absolute zero-ish kind of temperatures. We're going to talk about room temperature superconductors lately in relation to fusion. Some of the fusion technologies are trying to use some of the newer superconductors so they can generate these huge magnetic fields to contain this plasma. And the same thing would exist in generators. The two driving factors here. The cost of the material tends to be high, and if you're making one fusion reactor, that's probably okay. If you're making thousands of wind turbines, probably not okay. And the temperature does matter still, so you got to drive the temperature down, which is difficult to do in remote locations. On offshore wind, you really have no control over that. So, I think the superconductor has been held out as a like fusion, right? It's this sort of thing that we're getting close to. Like fusion is now described as an engineering problem, and superconductors are kind of becoming an engineering problem. We understand sort of what's happening there, and now we're putting engineers on it to get the last couple of yards, using the football analogy, towards the end zone. So the real kicker, I think, is cash, right? I think the fusion technology is all about cash. I think the superconductor is all about cash. And you throw enough engineers, you pay them well enough, eventually they'll come up with a good solution. Usually, if there's a way physically that it can be done and the physicists say, yeah, we can do this, then the engineers can get their heads around it and turn it into a product. And I think that's kind of where we are with a lot of things in wind energy right now, is that we have these sort of jewels that are dangling in front of us that we just can't grasp yet or turn into something usable. We're going to get there. It's just not today. And this is why it's so important that we don't always focus on the today. We're making wind turbines. It's pretty awesome. And we're making 15, 16 megawatt turbines. But we also have to have that R&D part, and Rosemary was part of that R&D part for a long time. That future, what's that next generation look like? How do you make these things better? You still have to devote money to it, and we're in this weird economic place where I don't think a lot of R&D is going on in wind.
Yeah, but I do know that this is one out there technology that the major manufacturers are working on. I know at least 2 or 3 of them. I know people working on those projects because when I was getting ready to leave my old position, I was looking around for what really cool, exciting things were happening in wind, and that was definitely one of the more forward-thinking things where there was like a big technology jump that needed to be made to get this working. So obviously the benefits are going to be big when they get it working. But it does kind of seem to be one of those technology like fusion is always 20 years away. Maybe this isn't 20 years away, but it does always seem to be, like 3 years away perpetually. So
can you dive into those? So you said those benefits are going to be big. Can you dive into those a little bit? Like, what are the core benefits? Obviously, they get bigger. This is a smaller generator, but take us through it a little bit.
Oh, well, I mean, I'm so not the expert on that, but it's improved efficiency and reduced use of materials. And then, of course, any weight that you take out of the top of a wind turbine makes everything, from that point down easier. So I guess the benefits are maybe quite simple. It's the implementation that's hard. That's all I can really say.
But I mean, I know obviously as they continue to try to push to bigger megawatt outputs, I mean, are they going to hit a bottleneck where, towers are going to have to be so big and heavy to support these that it's going to be like, hey, we kind of really need to get the superconductors to market now if we want to get to, say, 20 or 25 or 30? I mean, is that something that we're going to be approaching soon?
It's interesting because it's one thing that I think about a lot, and everybody's thinking about a lot. I mean, it's the most obvious thing about wind energy technology evolution is that turbines get bigger, right? Just perpetually just bigger beyond anybody's, what you would have said 10 years ago. Can blades get over 100 meters long? Like, no way. And here we are. They're there. Yeah. So the fact is, though, that at any one point, like lots of parts of the system are at their current limit, and it shouldn't make sense to just go bigger from the point of view of many components. I mean, it's nice to have fewer connections, especially for offshore, and yeah, it's nice to have fewer generators, fewer of everything. But, if you make a wind turbine blade twice as long, then you get twice as much power from it. But you probably making the weight of the blade much more than twice as much, probably, 4 times if you're just scaling directly. And, technology improvements bring that down a little bit. But definitely as turbines have got bigger, the blades have become more expensive and a bigger proportion of the cost of the turbines as well. And then we move on to things like carbon fiber, which reduce weight but cost more. I mean, it costs more to make a blade with carbon fiber than an equivalent one made with glass, but you do it because taking weight out of the blades means that you can take weight of everything else all the way down, starting with the bearings and finishing with the tower and foundation. So it's difficult to say where's it going to go, because it's like, which components technology, how are they moving relative to each other? So if blade design keeps on improving fast enough that that's not the constraint, then I guess we could see the generator size of the generator and the tower be a constraint. I mean, my background's blade, so I always think of that as the hard part. But I guess if you're a tower designer, maybe it's offensive when I say, that's the easy part. You just make your tower thicker. And, I know that they're running into some constraints with onshore wind towers, because to make a tower like 150 meters tall, you're really going to start to want to increase the diameter of the tower, and that's hard to transport. But they'll solve that with some 3D printing of the base of the tower or a lattice on the bottom. There's always, you never know when a new constraint emerges, then a new way, there's a new incentive to solve that constraint that wasn't there before. So I don't know. That's why this job is so interesting to be involved, because you can't predict the future that well.
Rosemary, I think you nailed it in the sense that we already are looking at spiral winding and laser welding towers on site just for that reason, which is a really innovative thing. And I've just been a little blurs about it, so it's just kind of not really known to the public. I've just seen little bits and pieces to it, which is really cool. But yeah, I mean, you're going to have to solve those problems in a unique way. And in terms of like the growth of wind turbines versus like your Jurassic Park equivalent, we're kind of in the Tyrannosaurus Rex size wind turbines right now. We're headed to sort of Brontosaurus size wind turbines. And after that, right, it gets really hard to make them any bigger, right? You're kind of going to have to reach some limit, because the thing just weighs so much, you can't move it around. And with bigger is not always better. And I'll give you the example on airplanes, like the A380, beautiful airplane, by the way. It just really didn't sell. And the 747 is going away too. So sometimes those bigger things can be more problematic and have extra constraints to them that you wouldn't have considered. And they're really expensive. You got all your money poured into one asset. It may not be the most efficient asset either. So sometimes having more smaller can be better than one bigger. And I think we're really close to that now. Maybe you think different. I'd love to hear your thoughts on that.
I think the same, but I am aware that everybody has thought that at every point for the last 20 or 30 years, even everyone thought we were close to the limit. So I also instinctively feel like we are going to get to the point soon where it starts to be cheaper to not go bigger, because I mean that's what it is at the end of the day. It's what's the cheapest arrangement to get the same number of megawatts or gigawatts. But yeah, I mean, history says that I'm probably wrong when I say we're close.
Well, Alan used a football analogy earlier. Do you want to throw in a rugby one real quick before we wrap up the show?
Well, I would have to use an Aussie rules one because that's my kind of football. I played for I think 5 years, and that's the best team sport that there is. Yeah, no, I can't think of one, but I'll take that as homework to incorporate a Aussie rules analogy for the next show.
Okay, well, look forward to that next week, and thank you for listening this week on the Uptime Podcast. Be sure to subscribe wherever you're listening, on iTunes, Spotify, Stitcher, YouTube, wherever. Be sure to leave us a review, share the show with a friend, and we will see you here next week on Uptime. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.